Want to be a master at spotting the odd one out using Python? Stick to the end of the video. A few years ago, when I was starting to learn a little bit of Python, I was thinking what would be a fun project to show off my Python skills. And Where's Waldo came to my mind because I was trying to do a lot with images, processing images, manipulating images, and I was thinking, okay, this would be a nice challenge to find this intricate pattern, so Waldo, in a bigger image. And I came upon this repository here. Well, I don't remember if it was this exactly, but this is the exact type of code where the creator of the repository said using just OpenCV and Python, you will be able to find Waldo. However, once I went through the code and then a little bit more through the actual uh, details of the description, I noticed that this wasn't really finding Waldo. What it was doing is, well, it had an image where Waldo should actually be in, um, cropped the Waldo image from it, and then using Python made it so that you would think it found Waldo while it was actually showing you where it found the cropped image in the bigger image. Well, this wasn't correct to find Waldo, but it is a good approach to find the odd one out. And let me explain how this is done. So using OpenCV and template matching, you can actually use the format to find the odd one out. How do you do it? Well, you have the big image, and from the big image you crop the smaller image, and then you just tell Python, if you find multiple instances of my smaller image, then please mark them in my image and show the results in a separate image. The whole code is right here, like I said. So you're reading the image. This is the Mario JPEG. You're putting it to grayscale. Then you're giving it the template to match. And this is actually I would say the biggest or the most important part, the threshold. The threshold based on which to actually do the matching. We will play around with that in a few seconds, but keep in mind threshold. And what it's going to do is going to find all of the places, like I said, where this image is, and then create a separate image showing us um, all the places. Now, in our use case, finding the odd one out, that would mean from a bigger image, we get all of the non-odds marked and the odd one out is not marked. Let's see that in action. So I have the same code or almost the same code as before. And the only thing I did was change the threshold, but let's change it to 0.8 because it was 0.8 before. And we have these two images. So we have this spot the odd one out. And which one am I taking as my reference? Well, I'm always taking the first one here because the probability of this being the odd one out is slim to none. I mean, if that's the odd one out, then I just figure everything out without needing my Python code. And then I create a smaller image of it and I feed it to the Python code. Let's run this. We should get the result.png. Now, this is what I was saying. You see, everything is red, and this is actually due to the threshold. The threshold, I would need to modify it a little bit, but you need to be careful while modifying, because if I put something like 1 here and then run the code, I get nothing. Okay, that's bad. So let me put 0.9. We run it, look at the result, and as you can see, this is full of marked images except for one. And this little one is actually our odd one out. Now that you see it there, it's visible, it's clear, it's absolutely fun. And here is how this is done. So with Python, with OpenCV, with a little bit of code, a little bit of creativity, you are now the master of spotting the odd one out. As always, thank you for watching the video, and I will see you in the next one. Have a good one, and bye bye.